Hello, everyone. So, in our journey to learn SQL for data engineering, what we're going to do today, we are going to look at another powerful technique, which is called set operations. And we're going to look into the power of it in the demo today. But from the theoretical perspective, sets are one of the major player in doing the data warehousing. Remember this concept in your mind. Try to practice it a lot, because once we start building the data warehouse, you're gonna see. You remember once we talk about the incremental load, the slowly changing dimension, these concepts, there are multiple techniques but one of the technique we can use is actually use the set operation, which obviously allow you to get the increment, instead of creating the full snapshot on every day for your data set, which is obviously unrealistic in the enterprises. But in some data areas we can do it. It really depends upon the table size. But to do that, we first need to understand the concepts of the set. So like I always mention, consider the table as a set where we have multiple data points which are sitting in there, and that concept will really help you to map the data for your machine learning activities later in this course, especially once we move away from data engineering and then we start another course for data sciences. These concepts really help you a lot. So your concept will translate from data engineering to data science smoothly. Like, you don't need to learn something new, because eventually whatever we are feeding into our machine, that is a data, and data is stored obviously in a structure format, and one of the obvious structure uh, is the table, which we use to feed the data. Now that table convert into the file, or you can say a record set or the feature set. But eventually, if you look at, it's a table, because we are feeding the the raw data set to our machine learning algorithm, right? So we need to understand, and I'm not talking about unstructured data at this moment, because that will unnecessarily complicate the things. Let's keep the discussion around the structured data sets. But once we move away, once we get the expertise on the structured data sets, then we move towards the non unstructured data, where we see how we can manage even unstructured data in terms of arrays if you want to feed them into the machine learning models or algorithms. So they are far in our journey. So coming back to the discussion, obviously, so that table, it obviously contains rows. Up to now, we have seen the table contains rows, and that row is consist of different columns or attributes. So these columns combined to each other create one data point, which is sitting within that table, which we call the data space, right? Now, obviously, once you understand that, if you try to convert it into the mathematical concept, if you don't understand math, that should be all right. Don't worry about it. We're going to actually discuss it from the non-mathematical perspective as well. But just to give you the comparison, especially in math, once we have these sets and then we compare two sets and find out what is common, and if we want to merge together two sets, then the union of the two sets will be the output, the combined output of both sets, and then obviously except will bring the one side which is not existing on the other side. The same concept apply on the SQL, on the tables as well. So once we apply these operation on the tables, like you can see from the conceptual perspective, if we are applying the union on two tables, then we are combining the output of two tables. One thing, obviously, we need to make sure that both tables are bringing the similar output, right? You cannot actually union between apple and oranges. I think you get the concept, right? So you need to get the similar data set that you want to combine. And what could be the requirements we're going to see in the demo today. Similarly, if the intersect is more like, the inner join concept that we have seen previously in the join video, where we bring the data which is common on both sides. The only difference between inner join and the intersect operator, in inner join it only use a key which is common on both sides. However, uh, in the set operation, it used the full row to compare against the other against the row on the other side. If both rows match, then it will bring into the final result. If rows are different, it won't bring. So now you can see if your scope changed from finding the rows between two tables which are not only similar or different at the key level. Obviously now you know what operator you need to use to actually get that output. And then obviously we have two flavor of union. One is union, the other one is union all. What's the difference? So you can see in the diagram, the union will bring everything from table A or from table B, but whatever is common between them, it won't duplicate them in the output. Like it only bring it once. So obviously we have some record sitting on the left hand side. You can see it's in the light yellowish area, and then obviously some record is sitting on the other side, which is obviously the parrot green area, and then we have light purple in the middle, which is showing the common. So that common record, they only appear once in the union clause. But if you want to show the full data set, regardless whether some records are common on both sides or not common, you want to bring both output and then merge them together. For that, you need to use union all. So you can see in the second shape that union all bring actually whatever is in the first set, and the whatever is in the second set. I didn't put the overlap in here because that's actually telling you the concept that it will bring everything regardless of the overlapping. So in other words, it totally ignored the overlapping. So that's why I actually put a two circle diagram and color the full circle. So that means the whole output is going to come in the final output as a result of union all operator. Now the third one is intersect. What intersect is doing, like I mentioned previously, intersect will compare both data set, and whatever rows are common between these two data sets, it's going to actually, or between these two tables, only those rows will appear in the final output. And intersect, except is a very special operator. Sometimes if we want to minus one table to another, so you can see the subtraction. So what subtraction does at the table level, it only show you those rows which are sitting in the table one, and which are not existing on the table two. So what does it mean? It will ignore all the common rows, as well as it ignore all the rows which are sitting in the table two and which are not part of the table one. So that operator is also very powerful, especially once we want to see is there any new record coming into our data source table, and we need to compare it with the existing data warehouse table. We normally use except. How we going to do it? We will discuss it into the data warehousing videos. So I think enough theory about the concept. Let's jump straight into the demo, and we're going to see all these operator in action. All right, so we are back into our SQL Server environment. You can see we have a scenario in here. So before we proceed, let me explain this scenario. We have the employees table in our database, and in that table, it's a view at the moment. So what we're gonna see, it's gonna actually provide us a consolidated view of our employee information. And we haven't discussed the tables, view, and other objects of the SQL. So just consider it as a table at the moment. Just imagine we have a table which is bringing us the employee information. Now, we have the salesperson information as well. And obviously, you can imagine the salesperson context is limited compared to the employee, because salesperson view will only bring you the information about the salesperson who are working for the company, who are working in the sales department. Right now, what we are going to do first, as a first step, we are going to write a union, because we want to see how many total records we are getting. So is there any salesperson which is not sitting into our employee? So for example, if we enter some external entity information directly into the salesperson information table, and which is not part of the employee table, so in that way we're gonna get obviously more records from the employee table, because that is not going to come in. Sorry, the total is going to be the combination is more than these two tables if we have any record sitting in salesperson which is not part of the employee. So let me run it. It's giving me 290 records. So that means this table is fully contained in it, because like I mentioned, union table. So let me just write down. So I think that would be much better. Let me first run. So we have 290 employees. I think that would be better. And we have 17 salesperson out of them. All right. Now let me run the union again. Now I can show you. We are as part of the union of these two tables, we are still getting 290 records. So that means we don't have any record which is sitting on the salesperson table, which is not part of the employee table. Sometimes these sort of reports we run from the data quality checks, right? So that will ensure us all our salesperson, they are part of the employee information, right? So that's the tick, and we know that okay, all salesperson are in the employee category as well. Now the next one, like I mentioned, if we want to see the full output, we are going to ignore the duplicates, and we bring the whole information on the screen. By the way, that's not a good scenario to use the union all. We have multiple occasions where we need to bring the full set. But let's see. We are getting 307 records, which is obviously 290 plus 17 is equal to 307. By the way, there is a technique if you want to just cross check. And now we are moving towards a bit complicated scenario. Now, because we know that we cannot apply further transformation, because that is the combined output. If you want to use that output as a plain table again, you can put them into the SubCurie. And if you remember your SubCurie concept from the previous video, I'm just going to put link back into this description. So if you it's going to be a refresher for you, have watched that video first. If you don't understand the SubCurie, you can write the SubCurie, and it will help you to apply further transformation. So for example, I put these two together and I union all, and now I know I am getting 307. Now, for somehow I want to distinct the records to get the unique record. So I'm just going to run it, and you can see we are getting again 290 record. So these sort of operations we can apply, and now you can see how things are shaping. That's one of the powerful area of SQL. Like you can apply these transformation to shape the data. In a way you need it, and that's where SQL really shine and standing aside from other languages, which provide you a very strong capability to change and transform the data in a way that is required, and then you feed it into either the data warehouse, or on your data marts, or even in your machine learning model, right? So that's the key. That's where the most of the time we spend to prepare the data, to shape the data, right? And all these operations which we are learning, these are all related to shaping the data in a way so it can help us to load it into our warehouses, data marts, or machine learning model, so these containers or consumers can do their work. So just an example, I'm just taking it out, keep it. So we have seen the union. Now what I'm going to see, I'm just going to check that is there anything which is not present, like we have already seen it. So intersect, what it is, what intersect is doing, like I mentioned, intersect will only bring those records which are common between two tables. So for example, I know that some columns are equal and some are not, but in order to just confirm that, okay, the rows on both sides, they are fully equal, we just need to see, because we are not looking at the key column anymore. We want to make sure the whole row needs to be common between these two tables, and intersect only bring those records where the whole row is common between these two tables. So if we have that kind of validation that we want to perform, we use the intersect operator. So let me just run it. And by the way, the efficiency or the speed is not related to the script. It's more like the virtual machine, because the virtual machine is running a bit slow due to the other work which is happening in the background. So it will be back in a moment. Theoretically, it shouldn't take that long. Yeah, so it's here. So it has nothing to do with the SQL Server. It's more like the virtual machine. My virtual machine is overloaded. I think I just need to reduce the load on the host machine. Anyway, so you can see we have 17 record, which is equal to the salesperson. So I know now that the salesperson is fully contained within the employee record, like none of the attributes are different from this data set between my salesperson and the employee, just part of the validation that you want to perform as a data quality checks. And now last but not the least is the most important one, except. What except will do, it will bring all those records in from the employee table which are not salesperson. Let me put this way. So if you want to see, okay, I've already seen, okay, salesperson are coming as a common record between these two tables, but I just want to show see all those records which are not salesperson, and I want to display them from employee table. So we will use except, because except will more like bring those records which are not a salesperson. Let me run this one. Now you can see how quickly it has executed. So it's just a random server thing that took some time in the previous execution. Now I can see the total is 273. So if you just do a quick calculation, if I subtract 17 from 290, it's going to be equal to 273. So all these records, they are those records where the employee is not salesperson. And we can even see from the job title, these are different titles which are coming from employee table. So that's how we use the set operation in SQL. Obviously, they're gonna make more sense once we build the solution using these concepts, especially like I mentioned in the data warehousing. It will really help us to to implement the slow changing dimension version 2 or type 2, and I'm going to show you how we can use part of these set operation to do that. So hopefully you like the video and it will be helpful for you to understand this set of question. Please feel free to put any comments if you have any question or like the video, and I'm gonna see you in the next one. Thanks for watching.